Okay, so it sounded like you had an issue determining where second derivative is positive and where it's negative. So here is the second derivative, 12x squared minus 12x minus 8. We'd like to know when that equals 0. And what we're doing is testing for concavity of the original function and identifying possible points of inflection. When we're solving this quadratic equation, we could factor out a 4, or we could divide every term by 4 and make the numbers a little simpler. Looks like it does not factor, so we use the quadratic formula and get 3 plus or minus the square root of 33 all over 6. And we're going to put those numbers on the number line. And we'd like to get a test number in each of the intervals created by these possible x coordinates for points of inflection. So I kind of estimated what this is. If I use the square root of 36, I'll have a number that's slightly bigger in the positive direction than what the actual x coordinate is, but that reduces to 3 plus 6, 9 over 6, so 3 halves. So I know if I pick a number to the right of 3 halves as my test number, that I'll be in the correct interval. And between these two x values, I'm going to pick a test number of 0. And to the left of this negative value, I'm going to pick -1. That should be small enough in the negative direction. And now if I plug these test numbers into the second derivative over here, I want to figure out what the sign of the second derivative is. If it's positive, that means the tangent lines are increasing in slope because the second derivative is the derivative of the first derivative. And the first derivative is the slopes of tangent lines. So what this tells us is that when the second derivative is positive, I like to think of the smiley face, positive, concave upward. If I find f prime of 0, I see I'm always going to get a negative number if I pick a number between these two x values. And so that's the frown, negative, concave down. And to the right, f prime of 2, f double prime of 2, I get another positive number, concave up. So that's how you find out where the second derivative is positive and negative. Find out where it is 0, and then pick test numbers in the intervals created by those x coordinates. And here's what the graph looks like. This is the graph of f, and this is what we call a point of inflection. It's where the concavity changes from concave up to all of a sudden it becomes concave down. And when we get over to here, it becomes concave up again, which means, again, if you drew some tangent lines, you'd see that the tangent lines are below the graph. They're increasing in slope. Okay, there you go. Hope that helped. If you have any questions, post a comment.